Hello. Now we'll talk about raising in the exceptions. Right? Again, this exceptions workflow, it can be initiated with the raise statement that we have already discussed, right? And to raise an exception, we need to raise the object of the exception type, right? So again, like you cannot raise an exception if it is not from the base class instance, if it is not inheriting from the base class. Consider this example over here. We have this class. This class is not inheriting from the base class. When we say try raise person, this will this is not the exceptions we have raised. It says that exception must be derived from the base exceptions. So if you are creating any exception, that has to be derived from the base exception or the exception class, right? And all the standard exceptions derived from the base exceptions can handle multiple positional argument, right? Like over here, we are getting the object of the base exception. We are passing the three string argument. We can check exe.argument, which will give you all the value. You can also check the string representation of the object. You can also check the REPR representation of the object, which will give you the name and the argument both, which means that other standard exceptions that inherit from the base exceptions also support this multiple argument. Like again, let's see that with the value error, we have this three argument. We can also see that this thing is also possible with the value error. And since the value error is inheriting from the base exceptions, but we often use only a single argument. Basically, we use only a descriptive kind of message in the argument, but we can handle or we can have the multiple argument. Again, here consider that to raise an exceptions. So here we'll use this raise keyword. We'll use this exception class, and then we can pass some message over here, some descriptive message in the try block. And in the accept block, we are handling this value error, right, and trying to print the representation of the object. So this is the representation of the object we have. But there are some useful variant of the raise statement we have. Sometimes we want to catch the exceptions, we want to handle it, or maybe we want to log something and after that we just let go that exceptions to propagate it through, right? So we can do that. Like over here, consider this example. If this function called divide, we are taking this two argument a and the b. Now we're trying this code, and if this zero division error happens, so here we are saying print logging. We are just printing this logging zero division exception. We are printing the type of the object. So this we are printing the name of the object class and then the arguments. And then after that we are saying raise. This means that after this print, we'll raise the same exceptions, right? So let's see this. Here we are just running the functions. We can see that because this is a zero division error, we can see this message. And here we are printing the name of the object type, the name of the class, and this is the argument, default argument that we are printing. And after that, when we said raise, this will raise this same exceptions. So we are not controlling it, we are just letting it go to propagate throughout the code, right? Sometimes we may want to change the particular exceptions we are raising, and this is particularly happens when we use a custom exceptions, right? So here consider that. So consider that we have this creating a called here we are creating a class called custom error. It is extending this inheriting this exception class, right? This is a simple docs, right? Now we have this function called myfunc. We are trying this code. If the zero division happened, if the zero division error happened, we are just saying print logging, and after that we want to raise the custom error, right? So here after this handling error, now we are raising the custom error. Sometimes we want to do that, we can do that with the raise keyword. Here we can see that. Can you see this? We had the zero division error, and then we are running this custom exception, and now we are getting the at the last we are getting the custom exceptions. But here you can see that the trace back. Here you can see the trace back, right? First we have this zero division error, and then we came to this custom error, right? So when we raise the exception in this way, the stack trace, this stack trace of the current exceptions is maintained and added to the new exceptions, right? We can see this in the nested at a more level. Like over here, we can see this. We have the raising the value error. We are handling the value error. Now again, we are trying the type error. We are handling the type error. Now inside this, we are trying the key error. This is a nested exception we are trying. And we run this. First, we can see the value error happened, right? The level 1. Then during handling this, first, then after that, it raised type error. After the value error, it raised type error. Level 2. Then after the type error, it raised key error, which is level 3. You can see this entire stack trace, right? Sometimes we may want to modify whether we want to keep the original state trace or not, right? Sometimes we may be writing a function where the specific exceptions that result in the final exception we want to raise, right? So for that, sometimes we may want to only just show that specific part of the exceptions. Sometimes, like let's say that I just want to see this key error. I do not want to see these exceptions. How to do that? For that, we can use this raise exception and then we can say from none. So here, from tells Python what trace back to use. In this case, it says none. That means we do not want to use any trace back. Right? Let's see that. Here we have the same function that we have used. We have this conversion error. We have this convert integer to convert the. Again, we have used the same code in our earlier class, right? So this is our convert integer. This is our convert string. Then we are creating a function called make boolean. First, we are trying to convert the integer, and then we are handling the type error. Then we are trying to convert string. Then we are handling the type error. After that, we are using the conversion error, and if the error happens at this block, then we are handling the value error, right? Inside this, we are handling the conversion error, right? And else will return B. So we have used this code. Let's see how the traceback looks like when we run the code. We can see first the type error, then the value error, then the conversion error, and the last here we are getting. And what happens if we do this code? Again, we have the same code, but here we have just changed over here. Here we have said from none, and here also we have said from none. This means that we do not want to use a traceback from any of the above. Let's see that in action. Here we can see that when we say from none, we are only getting the output at the conversion error. We are only getting output of this or this. If the exception will happen from here, but in this case, the exception has happened from here, right? So we have got this entire traceback, right? When we say make boolean 1.0, in this case, our exception has happened from here, right? So we are seeing only the specific part of the exception, not the entire traceback. We can control that from none, right? We can also be very specific as to which traceback to use and when we raise the exception. Like over here, consider this code. We are not controlling any exception over here. So let's see that. Here we are seeing the value error, again the level 1, level 2, level 3, right? And then we have the value error as value error occurred right here in the last exception. So all the exception we are printing, right? We can remove it entirely, right? And here we can say that here we are saying that in the last we are saying from none. In the last, in all the code here, in the last exception we are saying from none, right? And when we run this, what happens? We are only seeing this raised exception. That's it. We are only seeing this raised exceptions. We are not seeing this entire trace back from where this exception is happening, right? But we could also choose to skip some of the exceptions. Like over here, we are trying to skip the level 2. Here, in the same code, we have the level 1. So the object name is ex1. Here the object name is ex2. Here the object name is ex3. And here we're saying that we want to raise the value error, but from none, we are saying from EX1. When we say from EX1, this will remove this, or like this will trip this EX2 exception or the exceptions 2, right? Let's see that. Here we have got this exception 1, label 1, but then after, in between there is no exceptions. In between we have only got this exception, because this exception is in the code of this. So the moral of the thing is we have stripped this exception class by using from EX1. So now we'll see this exception, and now we'll see last exception. That's it, right? So this is how we can control raising the exceptions, right? So this is all about how to design the exception class. Thank you very much.